Now hey guys, in the last video we're gonna be talking about the power and its direction. So power can be found using Poynting's theorem. Poynting's theorem is simply such that P is equal to E cross H. So the E we found there crossed with H. So Poynting's theorem is saying that you can find the direction of power flow is in the direction of propagation. Direction of power flow is the direction of propagation of the wave. So it can literally be a Poynting vector pointing the direction of power flow. Okay, so the Poynting's vector, finding it, Poynting's vector is going to be, now our E was E naught e raised to power minus alpha z cos wt minus beta z times over z naught, now e raised to power minus alpha z cos wt minus bz. Then let's say that E propagates in the x direction and H propagates in the y. Remember, perpendicular. So that means you have times AX cross AY. AX cross AY would give us AZ. Okay? So now when we multiply everything, we get E naught squared E minus 2 alpha z over z naught cos wt minus bz cos wt minus bz. Now one thing to note, your z naught, like we said, can be written like z naught this e raised to power j theta. If we put this, remember our remember the formula for ET. For H, you know that H would be H in T. It's going to be E naught e raised to power minus alpha z over z naught e raised to power j theta. Now this theta is our theta is our characteristic impedance theta, and then this is going to be dot e j in a bracket wt minus bz. Now I can put this ej up, and et or ht is going to be e naught e minus alpha z over just z naught magnitude dot e j wt minus bz, then dot e j now will be minus j theta z naught, and that is equal to e minus alpha z over magnitude of z naught. Now it's going to be dot e j wt minus bz minus theta z naught. And remember what we said, that's going to be we're only going to consider the real side, and the real side is just bearing cos. This is our r, and then cos of our angle, so we have theta. So that means ht going to be e naught e minus alpha z over z naught cos wt minus bz minus theta z naught. So I can replace it down there as our Poynting vector. No, it's actually curved. That's how the P looks like in the Poynting vector. It's weird. So I can replace it as e naught squared e minus 2 alpha z over z naught magnitude cos wt minus bz cos wt minus bz minus theta z naught. Now it only affects your H field. So your H field is shifted. Its phase is shifted even further. All right. Now, but cos A cos B is equal to 1 over 2 into bracket cos A minus B plus cos A plus B. Remember your 312. So putting back in the equation, we get our pointing is going to be E naught squared E raised to the power minus 2 alpha z naught over 2 here into bracket. Now our cos A is W naught BZ minus W naught BZ minus theta. It's just going to give us theta Z naught straight up. Alright, then we have plus. Now the other one will be WT plus BZ plus WT minus BZ plus WT minus BZ minus this is going to give us cos 2WT minus 2BZ plus theta Z naught. And that is our pointing vector. Now remember that A cross Y is AZ. So it's going to be in the last coordinate. This is our pointing vector. Now to find the power average, the average power is going to be 1 over T integration of from 0 to T of our pointing vector. Now if we open our bracket, we're going to get E naught squared E raised to the power minus 2 alpha z over 2 z naught cos this z naught plus everything again. There's a reason why I'm going through this stress. Is to give a point that'll be valid throughout your solving of a power pointing vector. Cos 2 WT minus 2 BZ minus theta Z naught. Now, integration of cos will give us sine. But then, we're only considering the real part. And sine is of the imaginary part. So anything that has to do with sine will always be removed. So you see that the pointing vector will end up being just the constant, just 1 over T 0 to T of E naught squared E minus 2 alpha Z over 2 Z naught cos Z naught, because the other side has T and we're integrating with respect to T. So if we integrate cos WT minus 2BZ minus theta Z naught, we'll get sine. And once we get sine, we're already venturing into the imaginary and we're looking at only the real part. So therefore, if we put this, we have 1 over T times E naught squared E minus 2 alpha Z over 2 Z naught cos theta Z naught, then times T from 0 to T. But we know that when we put T here, T is going to cancel out. This guy is going to cancel when we put T. So all we have left for the average power is epsilon naught 2 squared E raised to the power minus 2 alpha Z over 2 Z naught cos this Z0. That is our average power. And now to find the total power, we have to find the amount of power passing through a particular, so the average power passing through a surface, and that's going to be surface integration of PAV average dot ds, and that finds the total power passing through a particular surface. And that marks the end of our tutorial. Although our PAV is also equal to 1/2 real of E cross H star. Now you see that H star is the conjugate of H, but I guess time has run out, so we may not be able to cover that. But this is the formula for power. This is the average power. This is your pointing's vector. So integration of the vector will give us our P average, and the integration of the P average in surface over a surface will give us the total power. And this brings a close to the tutorial on AIE 311. So this is where we started. We started way back. We started with Maxwell's equations, then with the diagrams, then we entered the derivation, converted it to our frequency domain. Then we found free space constant of equations in free space, but that won't really help us much, only for free space. Then for lossy dielectric was where we're able to find the real formula that would work for any situation, whether free space, conducting or non-conducting, or little conducting. And that's when we found our beta and our alpha, and we know that our constant is equal to alpha plus j beta. So with alpha and j beta we can find our propagation constant, and we know that that is equal to this squared mu epsilon for free space, and is equal to, or y squared rather, y squared is equal to W conductivity this j minus for, this is free space, and this is for lossy dielectric or a conducting material. Hope you had a nice time with the tutorials. Please do not fear, this is not something that is madly crazy. There may be a lot of numbers, but this is just simple math. Love you guys. I pray you have success in every single thing you do.